I was saying is what we did so far with reducing radicals and introducing that imaginary number and complex numbers were topics that we need to know for Unit 6. Now we're actually getting into the content of Unit 6. Unit 6 is all about quadratics. So we're going to be focusing this unit on solving quadratics. Okay, we're going to look at several different methods for solving quadratics. We're going to start today with graphing. Today we're going to talk about solving by graphing and solving by factoring. So graphing is going to be the easiest, I'm sure, because for graphing you get to use Desmos. Okay, so first off, before we jump into looking at the graphs, what does solve mean? When we have a function and we want to solve, that means to find the x-intercepts. We're looking for where does this function cross the x-axis. Okay, now there are different terms, some different vocabulary for that you need to know. Does anybody remember some of the different terms for x-intercepts? And you need to know these because the questions may use this vocabulary instead of just saying find the x-intercepts. If I ask you to solve something, what are you getting? What's your answer called? If you want to solve a problem, you're finding a solution. Good. So solution is one of the terms for x-intercepts. Okay, so solutions. Come on. There's two others. Okay, I don't know if you remember them from Algebra 1. One starts with an R. One starts with a Z. You're looking for your x-intercepts or your solutions. They're also referred to as... No? Okay, well, if I'm on the x-axis, that's where I have to be an x-intercept, right? What is the y value? 0. To solve an equation, you set it equal to 0. Zeros are another term that you're going to see for your x-intercepts. So your zeros. So solutions and zeros both mean x-intercepts. Okay, there's one more. It's the one that starts with an R. Nobody recalls it? It's your roots. Okay, it's like what is rooting your graph down. The x-intercepts are the roots of the function. All right, so graphically, what I was saying is we're simply going to input an equation into Desmos and view the graph. Now, if the graph is already given, you obviously don't have to do that. Okay, that's if you're just given the equation. Okay, if the graph is given, we can just look at the graph. Your solutions are your x-intercepts. That's the whole thing we were just talking about. So we're just simply looking, where do these graphs cross the x-axis? Okay, so this first graph on the left, that's happening here and here. So it's happening twice. So this graph has two solutions at 2 and at 6. Okay, and remember these are our x-intercepts. So this is what x equals. Okay, so I could say x equals 2 and 6 and just list out the solutions. Okay, you may also see them listed as ordered pairs, as actual coordinates. Okay, so we said, or I said just a second ago, that if I'm on the x-axis, what is y? 0. So when you write it as an ordered pair, remember your y is 0. That's why zeros is another term for this. So you may see your answers listed as 2, 0, and 6, 0. Okay, this graph on the right, how many solutions does it have? 2 as well. Okay, so it's crossing the x-axis here and here. So I may write that as x equals, and that's at -1 and +7, where you may see it listed as ordered pairs. Okay, but both of those had 2 solutions. Will all quadratics, so quadratics all make this same shape, right? A parabola. Will all parabolas, all quadratics have 2 solutions? Do they always cross the x-axis twice? Maybe. Could it cross more than twice? Could this turn and come back down and cross again? The graph could turn and come back and cross again, but would it still be a quadratic function? An x squared function? No. Okay, a quadratic, that's when you have x squared. It's only going to make this parabola shape. If it turns and comes back down, it's not a parabola anymore. It's not a quadratic function. Okay, it's changing to a different polynomial function, okay, of a higher degree. So a quadratic is never going to have more than 2 solutions. Could it have less than 2 solutions? If I were to move this graph on the left, if I were to shift it up 5, so where that vertex is right here, if I moved it up 5 and the vertex was here, would it cross the x-axis? No. Would it still be a quadratic? Yes, it would still be a parabola. Okay, so it could have no solutions. It could never cross the x-axis because it opens in one direction. Depending on where that vertex is, if I moved this one down below the x-axis and it's opening down, it would never cross the x-axis. So you could have no solutions. So you can see down here, I have that a quadratic can have 2 real solutions, 1 real solution, or none. Okay, I just talked about, looked at 2. I just talked about how you could have none. If you had 1 real solution, what would that mean about where your vertex is? It's on the x-axis. So if I shifted this one up 2 to where this vertex is actually on the x-axis, it touches the x-axis. You have an x-intercept, but only 1 point, only at that vertex. Okay, so that's possible as well. If your vertex is your x-intercept, you're only going to have 1 real solution. And notice we're using that word real because we just got through talking about imaginary numbers. So now you know there's real numbers and there's imaginary numbers. So these are your possibilities for real solutions. So 2, 1, or 0 real solutions. We're going to look at each of those. Okay. So this first one is an example of a function, a quadratic function that has 2 solutions. Okay, so I'm going to show you in Desmos what we would do to look at this graph. Where's my Desmos? Did I close? There it is. All right, so that is this one here. Okay, so here is that graph. There's my origin. Okay, so this has 2 solutions because it's crossing the x-axis in 2 spots. Where does it cross? What are those solutions? At 2 and 4. And if you can't tell just by looking in Desmos, remember you can click on points and it will give you the coordinates. So that's definitely at 2 and 4. Okay, so I'm going to plot those on this graph here. So 2, 0, and 4, 0. Okay, what about the vertex? Where's the vertex for this one? If you can't tell it by looking, you can come and click on it and get the ordered pair. So that vertex is at 3, 2. Oh, it wasn't the best sketch. I totally missed that first point. Good enough. Okay, so I've got two solutions. My vertex, the y value of my vertex was positive, so it's above the x-axis, and my parabola is opening down. So it's going to cross the x-axis twice. Okay, let's check out that second one. So x squared minus 6x plus 9. Here's that graph. Where is the x-intercept? 3, 0. Okay, where is the vertex? What's the vertex of this one? Also 3, 0. So that's what we said. We said that for it to only cross once or touch the x-axis once, that means that the vertex is the x-intercept. Okay, so the x-intercept is the vertex. Now to graph this curve, I'm going to get a couple of additional points here. Looks like there's a point at 2, 1, and 4, 1. Okay. So this graph only has one solution. All right, let's check out this last one. I think I edited it for a different problem, so let me fix that. Oh. All right, so where are the x-intercepts for this one? Here's the x-axis down here. Are there x-intercepts? No, this graph never touches the x-axis. So there are no x-intercepts. Where's the vertex? At 1, 2. Good. So we'll plot that. It looks like there's a point, there's a y-intercept at 0, 3. But this one has 0 solutions because you can see it never crosses that x-axis. So my vertex was at 1, 2, and there are none. There are no x-intercepts. Everybody good with the concept that you're going to have 0, 1, or 2 real solutions for a quadratic? Everybody know how to type those? I know I had them typed into Desmos already. Y'all know how to type equations into Desmos, right? No questions about that? Okay, graphing's pretty straightforward. All right, so that is our graphing. So if you flip that page over to the back, now we're going to start looking at quadratics solving by factoring. Okay, now we did a whole little unit on factoring back last semester. You learned factoring in Algebra 1, and then we reviewed it in a unit last semester, and we introduced some more complex factoring. We talked about factoring by grouping, factoring with box method or area model. We did greatest common factor. We factored lots of different types of functions, not just quadratic. We did cubic and quartic and higher polynomial functions. Okay, today, this unit, we are just looking at quadratics, so only when there's an x squared. Okay, so I'm gonna, I know it says warm up, but we've already jumped into the graphing, so I'm gonna go ahead and warm up with y'all on these and just kind of refresh on some of our factoring processes that we learned and practiced last semester. So this first quadratic, notice how in the middle there's two x terms. Yes, we could combine those like terms and make this a trinomial, a 3-term expression, but when it's set up with 4 terms like this, it's set up to try grouping. So I'm going to review the grouping process with you for this one. So grouping, when you have 4 terms, you split them into 2 groups. You put the first 2 terms together, and you put the second 2 terms together. Does this look familiar? I hope. Okay, what do you do once you've grouped them? What are you looking for within each group? A greatest common factor, thank you. Okay, so in the green parentheses, that first group, 2x squared minus x, is there a greatest common factor of those 2 terms? X. They both can be divided by x. Okay, so if I factor out an x, hang on, what am I left with here? And if you actually need to show you're dividing each of those by x, you can show that if that helps you. Okay, so if I divide out an x from each of those terms, this first term would be left as 2x, and this term would just be a 1. So I have 2x minus 1 for the first group. Okay, what about the purple parentheses, the second group? Is there a GCF there? Is there something that both of these terms can be divided by? 3. They can both be divided by 3. Good. So I'm going to factor out, and that's a positive 3. And that would leave me with 2x and minus 1. Hey, isn't that a good sign? Isn't that what we want when we do grouping? We want those, I've been calling them leftovers this year. We want these leftovers here to match, don't we? That tells us we're on the right track. So that means 2x minus 1 is a factor. And then what's the other factor? What do I look at? I put those GCFs that we pulled out, I put those together to create the other factor, so x plus 3. So that's the factored form. And remember, we talked about when we did this with factoring back last semester, we talked about you can always use Desmos to check your factoring. You could type that original one in and see what that graph would look like. And then you could type the factored form in, and they should be identical. They should be equivalent to each other. Right? Okay. All right, this one over here, the second one under the warm-up is a trinomial. Okay, it's not split, that middle term's not split up to make 4 terms to set up for grouping yet. You could do that. You could try to do grouping here, but when your A value is an understood 1, it's actually probably faster, maybe a little easier, to just do guess and check. When we had trinomial quadratics, if you need to go back and look at these notes from last semester or review, the video links are still up. All of that is still there if you need a refresher. But we talked about factoring with guess and check, factoring by grouping, and factoring with the box method or area model. So you can go and review all those methods if you have forgotten. Okay, when I say A is an understood 1, what does that mean? Where is A? When we talk about a quadratic, what's the standard form that a quadratic equation is written in? Ax squared plus bx plus c. Very good. So when I talk about A, B, and C, I'm talking about the numbers. A is the number, the coefficient in front of x squared. B is the coefficient in front of x, and C is the constant. Okay, so here A is an understood, whoa. A is an understood 1 right there because there's nothing there. So when that's the case, it makes our factoring a little bit easier because we know we want to end up like this down here with 2 factors, okay? We want to split up that x to 2 factors, that x squared. So I can go ahead and write out my 2 sets of parentheses, and I know the only factors of x squared would be x times x. So then to fill in what is supposed to be over here in each binomial with the x, I can ask myself, what multiplies to give me c, but adds to give me b? So in this case, what multiplies to -6, but adds to -5? So if it helps you to make a list of your factors, so the factors, first of all, what about the sign? If it multiplies to a negative, what do I immediately know about these two? I have to have one positive and one negative. Okay, so you know your signs. So you're going to have one positive and one negative. Now the factors of 6 could be 6 and 1. So it could be -6 and 1, or +6 and -1. Or it could be 3 and 2. So -3 and +2, or +3 and -2. So you can list your factors if you need to do that. And we're looking for which of those, if any, will add to -5. Do any of those add to -5? +1 and -6. It's this first one. So -6 and +1. Those would multiply to give us the -6, but add to give us the -5. So that's it. That's factored. We're done. Some of you need to write out a list like this to get a visual and see, and you can mark out as you check and they don't work. Some of you can do this part in your head, and that's okay. You don't have to have a list written up to the side. Okay, but that's the guess and check that I recommend when that A is 1. Just ask yourself, what multiplies to C but adds to B? Y'all remember that? All right. All right, what did we just get through saying on the front? I'm just going to reiterate. What are the 3 words, those 3 vocab terms that mean x-intercepts? Anybody remember any of those 3? Zeros. Good. Roots. What was the third one? Solutions. Good. So the reason it's important to know all those is to know what the question's asking, because some questions will be worded differently. Some will say find the solutions. Some will say find the zeros, or find the roots, or what are the solutions? What are the zeros? What are the roots? Okay, so anytime those 3 or they may straight up say x-intercepts. Okay, so those 4 terms, x-intercepts, zeros, roots, solutions, they can all be used in the questioning. Okay, but when we are asked to solve as well, it could just say solve the quadratic. That means find the solution. That means find the x-intercept. Now, to do that, if we are not graphing, if we don't have a graph, we don't have our graphing calculator, we can find these by factoring. This is one of the algebraic methods for solving quadratics. Okay, we're going to find the zeros by setting the equation equal to 0. Because that's what it is, right? We're replacing the y or the f of x or whatever with 0. Because to find a 0, we need to set it equal to 0. Okay, so we set the equation, we have everything on one side set equal to 0. Then we're going to factor. It may be grouping like this. It may be guess and check. Okay, it may be GCF, it may be area model. Okay, whatever it needs to be. Okay, but we're going to factor. Once we have our equation factored, we're going to do what I like to call split and solve. Now, what split and solve means is we're going to come up with two factors because these are quadratics, so there should be two factors. And we're going to solve each of them separately. We're going to set each of them individually equal to 0 and solve to get up to two solutions. The reason that that works, the reason that we split and solve, comes from the zero product property. This is the property that says if the product of two or more numbers is 0, then at least one of those numbers has to be 0. Okay, here you can see what I mean. If I tell you that A times B is 0, either A has to be 0, B has to be 0, or they both have to be 0, right? For that to be true, one of them has to be 0 for it to equal 0 when you multiply. Y'all agree? That's the zero product property. So when we think about it with factors, if I have two factors here and I'm telling you it's equal to 0, that means that either this factor has to equal 0 or this factor has to equal 0. So we solve them both and figure out what those two solutions would be. Does that make sense? All right, so that's the process. This set it equal to 0, factor, and then split and solve. That's what we're doing to find our zeros. So in this first one, it's all set up, f of x equals, so everything's on one side, so I can just simply replace f of x with 0 for step 1. Okay, what's step 2? After we set it equal to 0, what do we do? What does it say right there? I'm pointing to what it says. Please participate. Factor. Thank you. All right, so now we're going to factor. This is a trinomial quadratic. So I have options. I can do guess and check. I can do box method. I could do it with grouping, starting with that X method that we learned and reviewed last semester. What is your A value here, though? Your A is 1. So my recommendation is going to simply be to do guess and check. Because you know the two binomials are both going to start with just X. Since there's no A value, it's an understood 1. So it's just going to be 1x times 1x. So if it were me, that's all I would do is guess and check. I would say, okay, I've got it set up, and now I'm going to ask myself what multiplies 12, positive 12, but adds to negative 8. Now let's think about the signs. If it multiplies to a positive, they have to be the same sign, right? Both positive or both negative. And I want it to add to a negative right here. So that right away tells me these both must be negative. Do y'all agree? So I know they're both negative. So I'm looking for the factors of 12 that will add to 8. So if you need to make a list, make a list. The factors of 12 and 1, 6 and 2, 4 and 3. Any of those add to 8? Is 12 and 1 8? No. 6 and 2 add to 8. 4 and 3 would have added to 7. So it's 6 and 2. We already established that they're both negative. So it's negative 6 and negative 2. Negative 6 times negative 2 would give us the positive 12, and the negative 6 plus negative 2 would give us the negative 8. So we factored. What's the next step? Set equal to 0, factor, and then what? Split and solve. So first of all, this is all set equal to 0. You can keep the 0 equals, or you can write the equals 0 on the right if you prefer. That doesn't matter. But I'm going to split. I like to physically draw a line to split the two factors. And I'm going to set each of them individually. I don't know what's going on with my stylus. Here we go. Equal to 0. So I'm going to say x minus 6 could equal 0, or x minus 2 could equal 0. I have to solve both of those and figure out what would make that 0. Now, some of you know it right away. You don't have to show work. You can say, oh, it's going to be the opposite. It's going to be positive 6 and positive 2. Some of you are like, what? How'd you know that? And that's okay. I'm going to actually do the algebra. If I'm trying to solve for x, I'm going to move this minus 6 to the other side by adding 6. So x is positive 6. Okay, here I would have to add the 2 to the other side to solve for x. And so I get x is positive 2. So those are my two solutions. Multiple ways you could check your work. If you have a calculator, a graphing calculator, you could, of course, just look at the graph and see if that's right. Are those where it cross? You could check it. Okay, if you don't, you can plug these numbers back into the original equation to check. If I plug a 2 back in here, 2 squared is 4. Okay, negative 8 times 2 would be negative 16. So positive 4 and negative 16, that's negative 12. Plus 12, that's 0, isn't it? Checks out. Okay, and then you could do the same thing. You could check 6. Okay, if I plug either of those in, it gives me 0 for my equation. Good? All right, so let's try that process again. This one is all set up all on one side, g of x equals, so I can just replace the g of x with the 0. So that's step 1 is set it equal to 0. Done and done. Now, what's different about this equation? What's missing here? There's no c. There's no constant. So this is not a trinomial. I don't have to do guess and check or box method or grouping. What type of factoring can I do here? Because there's no constant. These two terms have something in common, don't they? I can just do GCF factoring for this one. Okay, so what is the GCF? What can be divided out of both of these terms? They can both be divided by 3, and they can both be divided by x. Very good. So I take the 3x, and then I put in parentheses what's left. So what's going to be left in that first term when I divide out 3x? Just an x. Good. Okay, what's going to be left here when I divide out 3x? Plus 4. Now again, this is all still equal to 0. Now I'm ready to split and solve. Okay, I've got 3x as a factor, x plus 4 is a factor. Now, when you end up with a factor like 3x, like just a coefficient and then x, it doesn't matter what that coefficient is. In this case, it's a 3. You have to divide it over to get rid of it, right? And what's 0 divided by anything? So anytime you end up with a factor where nothing's added or subtracted to the x, it's just something times x, you know your answer, your factor there, or excuse me, your solution there is going to be 0. Because if I divide by the 3, still 0. Now, when your factor has a plus or a minus a number, it's always going to be the opposite. Good, because I have to do the opposite to move it to the other side. So that's just going to come out to negative 4. So I get negative 4 and 0 as my solutions. So if I were to plug in a 0 here, 0 times anything is 0, 0 times anything is 0 plus 0. Yep, that's 0. Checks out. And I could check the negative 4 and it would check out as well. Or I could go and look at this graph in Desmos and see, are these the x-intercepts? See if it checks out. So far, so good? So these are pretty basic. If you end up with a coefficient times x as a factor, you know it's going to be 0 for the solution. Or if you end up with x plus or minus a number, like any of these, it's just going to be the opposite. Okay, there are some more complicated ones. Sometimes it's not just x plus or minus a number. Sometimes there's a coefficient in front of x and a plus or minus. So we'll have to look at some of those too. Example 3 is not set up as straightforward. It's not set equal to 0 yet. It's not just y equals or f of x equals. So we've got to do some moving of terms to get it everything to one side set equal to 0. So I could move the 4x to the right, but notice my a value is a -1 right now with the x squared on the right. I don't like having a negative a value. It makes it harder to factor. So instead of moving that 4x to the right, I'm going to move both of these terms to the left so that this one becomes positive. Is everybody with me on that? Okay, so to move those terms to the left, I'm going to add x squared. And then I'm going to have to add the 4. That gets rid of both of those over there. So what is this going to be equal to on the right? What's going to be left on the right side? 0. That's the whole point. I'm trying to get this set equal to 0. There's going to be nothing left over there. Okay, now on the left, I've got an x term, an x squared term, and a constant. I can't combine any of those. I'm going to put it in standard form. I'm going to write my x squared term first, and then my x term, and then my constant. So far, so good? Now we're ready to factor. What's my a? My a is 1, so I'm just going to do guess and check. I'm just going to say, I know that my two binomials are both going to just start with x, and I'm going to ask myself, what multiplies? Come on, pen. There we go. What multiplies to give me +4, but adds to give me -4? Signs. It multiplies to a positive, but adds to a negative. What do we know? It multiplies to a positive. What do I know? They either both have to be positive or both have to be negative. And the fact that we want it to add to a negative tells us straight away they both must be negative. All right, what are the factors of 4? 4 and 1, 2 and 2. Any combination of those that will add to 4? 2 and 2. No, that looks like I marked it out. Here we go. We already established that they're both negative. So -2 times -2 would give me the +4, and -2 plus -2 would give me the -4. Those are identical. So when I go to solve this, I've done the factoring. The last step is to split and solve to set each factor equal to 0. If you end up with an identical factor or a repeated root or repeated 0 is what we call them, you don't need to solve it twice. Aren't you going to get the same answer both times? You better, okay? Or you're making a mistake somewhere. So I don't need to bother doing it twice. I'll just do it once. And what's the solution? 2. What do you think that means that I only got one solution? What did we say that meant? If there's only one solution, only one place our parabola crosses the x-axis, that means that that's the vertex too, isn't it? That makes sense? All right, let's try example 4. It's not set equal to 0, so I'm going to move that 2 by adding it. It's negative on this side, so I'm going to add 2 on this side. I'm getting real frustrated with all these extra marks the stylus is making, though. Okay, so now I've got it set equal to 0. Can I combine that minus 5x and that plus 2? Are those like terms? No, the 5 has an x, the 2 does not. Do not try to combine those. This will stay 2x squared minus 5x plus 2. So I've got a trinomial. Now this time is A 1? No, it is not. Now, that does not mean I can't do guess and check. It just means I have to be careful and pay attention to what I'm doing in guess and check because there's a little more to think about. Okay, but if that gets too confusing for you, you don't have to do guess and check. This is at the point last semester when we were talking about factoring. When A was not 1, I showed y'all factor by grouping and box method, and both of them started with the x. Y'all remember the x? We said put A times C in the top and B in the bottom. Okay, so remember this is A, B, and C. So A times C, that's 2 times 2 is 4. And B is -5. So we are asking ourselves what multiply, oh my gosh, the stylus. What multiplies to 4 but adds to -5. Okay, and I showed some of y'all, we talked about how you can do what's called an ACB table if you like to list out your factors, or you can just list them. It doesn't have to be in a table, but this could be 4 and 1. It could be 2 and 2. The fact that it's positive, they could both be negative. So it could be -4 and -1, or -2 and -2. Okay, but we are looking for the one that adds up to -5. So this adds to 5. That's not what we want. This adds to 4. Nope. That one is the one that adds to -5. Is everybody with me? So if it helps you to do a table like that, go for it. Okay, but we end up with -4 and -1. Now, what you do with -4 and -1 is you are replacing that middle term, that B term. Instead of -5, we're going to replace it with -4 and -1. So we're creating 4 terms instead of just 3. And we can set this up as grouping, or we can do it as box method. If you do it as grouping, it would look like this. You simply make that substitution in that middle term, and then you're ready to create your 2 groups like we did on that first warm-up question. So we put the first 2 in parentheses as the first group, and we put the second 2 in parentheses as the second group. And we look for the GCF of each group. So in the first group, that would be 2x. And if I divided 2x out of both of these, that would leave me with x minus 2. And then if I did the GCF here of the second group, I would just take out the -1 so that I'm left with a positive x minus 2. I'm going to go ahead and finish this. Y'all can check this recording to finish this one in advisory, or not advisory, tutorials, lightning lunch, or at home this weekend. Okay, so I've got my GCF pulled out here, and my leftovers match. So that means that x minus 2 is a factor, and then I put the 2x minus 1 together. And that's all still set equal to 0. And I'm ready to split and solve. So then on the left, I would add the 2 over. So I end up with x is 2. And over here, I would have to add the 1. but that's not just x, that's 2x equals 1. So then I have to divide by the 2. So I end up with x equals 1/2. So you don't always get integer solutions, and that's okay. All right, your other option there, instead of replacing and doing grouping, some of you might prefer the box method, and again, that's fine. You can go back to last semester's notes and review all of our factoring methods, all of our factoring lessons if you need to. I'll go ahead and show you by box method just for giggles. So this is grouping, label it. Hang on one sec, I'm recording. And this is box method. So the box method, you would have your 2x squared in the first box and your constant of 2 in the last box, and you're just making the substitution, replacement of the middle term, negative 5x, with the negative 4x and negative 1x. And it doesn't matter which one goes in which box. And you can write -1 or you can just write negative. We know that that's an understood 1. So then you're looking, when you do box method, you're looking for the GCF of each of these rows and columns. So in this first column, the GCF would be x. And in this second column, the GCF would be -2. Now, why is it negative and not positive? You always use the sign, pull out the sign of that first term. Okay, so since that first term is negative, we pulled out -2. Now in this row, the GCF would be 2x. And in this second row, the GCF, there isn't one, but that negative has to be pulled out. So it's an understood 1, but it's got to be -1. Excuse me. So what you pulled out, those become your factors. So you can see we have x minus 2 and 2x minus 1. And those are the two factors that we got over here. And then we would split and solve and get the same solutions. All right, so I'll stop that video here. We'll talk about number 5 next class. I'm supposed to have a golf tournament, but I'm pretty sure it's going to be rained out with our weather Monday. So Monday we'll go over this. If we do end up having the tournament, I'll have a recording showing you number 5. So you can finish copying down number 5, and then you're going to have some practice to do on Monday to practice the factoring and graphing ways to solve quadratics.